Day 585 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3583, count special triplets. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums. A special triplet is defined as a triplet of indices I, j, and k such that 0 is less than or equal to I is less than j is less than k, and k is less than n, where n equals nums.length. Nums of I is equal to nums of j times 2, and nums of k is equal to nums of j times 2. Return the total number return the total number of special triplets in the array. Since the answer may be large, return it in a module 10 to the ninth power plus 7. All right, y'all. So that may seem a little bit simple at first, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So in example 1, we have our input nums equals an array of integers 6, 3, and 6. The output is 1. The explanation says the only special triplet is 0, 1, and 2, or index 0, 1, and 2, where nums of 0 is equal to 6, nums of 1 is equal to 3, and nums of 2 is equal to 6. Boom. So it says nums of 0 equals nums of 1 times nums of 2, which equals 3 times 2, which equals 6. So we have nums of 0 right here is 6, right? And then nums of 1 times 2 is going to be equal to 6, right? So this is nums of 1. We multiply it by 2. That's going to equal 6, which is equal to nums of 0. Also, we have this right here, because remember we need a triplet, so it needs to be like this on both sides. So right here, we have nums of 2 is equal to nums of 1 times 2. So this right here represents this requirement right here. And then this right here represents this first requirement right here, where nums of I is equal to nums of j times 2. That's this right here. And then nums of k, because remember k is the third index, or the last element, right? So that would be nums of k equal to nums of j times 2 would be this one right here, right? So once again, we take nums of 0 is equal to nums of 1 times 2, because nums of 1 times 2 is equal to 6. They equal to each other. And then nums of 2 is also, or nums of 2 is also equal to nums of 1 times 2, right? Because we multiply this times 2, it'll equal this, right? So this right here, 6, 3, and 6, is our triplet. There's only one triplet in the array, so that's why the output is 1. So let's, just in case that didn't make sense, let's take a look at example 2, where there's actually more numbers than just 3 numbers, where there's actually more elements than 3. So in example 2, we have our input nums equals an array of integers 0, 1, 0, 0. The output is 0. Same principles applied. The only special character or the only special triplet ijk is 0, 2, and 3. So index 0, index 2, and index 3, where nums of 0 is equal to, or nums of 0 equals 0, nums of 2 equals 0, and nums of 3 equals 0, right? So nums of 0 is equal, nums of 0 is equal to nums of 2 times 2. So in this case, that's going to equal 0. Boom. Then nums of 3, so this would be nums of 3 right here, is equal to nums of 2 times 2, right? Boom. This 0 right here is going to equal 0. Anything times 0 is going to be 0. So in this case, the output is 1. So notice we skipped this 1. We didn't need this 1, but we just want the triplets. In this case, the triplets that we're using are all zeros. It's this 0, this 0, and this 0. So we just want to create a triple, or find 3 numbers in the element where we can create a tuple or triples like this, where triplet like this, where they will fit these 2 requirements up here. So in this case, we were able to find these 3 elements with these 3 elements right here. We didn't need the 1 So that's how we got an output of 1 by using this 0 and these two zeros over here. Those were our three numbers. Now, just in case that didn't make sense, let's take a look at example 3. In example 3, we actually have two triplets. So in example 3, we have our input nums equals an array of integers 8, 4, 2, 8, and 4. The output is 2. Explanation says there are exactly two special triplets, right? So the first one would be 0, 1, and 3. So that would be 8, 2, and 8. So it says, oh, sorry, y'all, 8, 4, and 8. Excuse me, 8, 4, and 8, right? Because it's 0, 1, and 3. Sorry, 0. This is 0, this is 1, and this is 3. So it'd be 8, 4, 8. So it says right here, nums of 0, right here, 8 is equal to nums of 1 times 2. So this 8 right here is equal to nums of 1, which is this 4 times 2. Boom. So that fits this requirement. Then it says nums of 3, which is this 8 right here, is also equal to, nums of 1 times 2. Sorry, y'all. And then this 8 right here is also equal to nums of 1 times 2, right? This nums of 1 times 2 is 4. 4 times 2 equals 8. So boom, this is our triple right here. 8, 4, and this 8, those three numbers. That's our first triplet. Our second triplet would be nums of 1, nums of 2, and nums of 4. So this would be nums of 1, this would be nums of 2, and this would be nums of 4, right? So now nums of 1 is equal to nums of 2 times 2, right? Because 2 times 2 is equal to 4. Boom. And also nums of 4, which is 4, is also equal to nums of 2 times 2, right? Boom, because 2 times 2 is 4. So we get this 4, this 2, and this 4. And then for the first one, we had this 8, this 4. Sorry, we had this 8, this 4, and this 8. And those were our two triples right there. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, the first thing we're going to do is we're going to handle our module operator by coming right here. And we are just going to say let mod equal 1 underscore 000 underscore 000 underscore 007. Boom. Then we need a place to store our final answer, or the number of special triplets that we found. So we could come underneath this, declare a variable called ands, and set that equal to 0. Boom. Then we need to see how many times value x has appeared so far. So we're going to declare a variable called count, set that equal to a dictionary. We're going to open up the brackets. We're going to say int colon, int colon int. Just like that, it's going to be a dictionary of integers. Then we're going to initialize it by opening up the parentheses. We're going to say minimum capacity, boom, colon. Then we're going to say nums.count. Then we're going to come underneath this. And then we're going to do the same thing. This one we're going to call pair count. And we're going to see how many pairs exist where nums of j is equal to x. So we're going to come underneath this, declare a variable called pair count. Pair count. And then we're going to set that equal to, we're going to do the same thing. Open up the square brackets. We're going to say int colon int. Open up the parentheses. We're going to say minimum capacity colon nums.count. Boom. Then we're going to iterate through the array. So we're going to come right here. And we're going to say for num and nums. We're going to open up the brackets and we're going to count the valid triplets. If num is even, we're going to check if it's previously formed pairs for num divided by 2, because a valid triplet might be ijk with nums of k equal to nums of j equal to nums of I times 2, and nums of k equal to nums of j times 2. So we can say if num and we're going to put one and sign, 1 equals 0. Then we're going to open up the brackets and we are going to say if let pairs equals pair count square bracket num. Come outside of that, we're going to say greater than sorry, not outside of that, still inside the parentheses. I mean, still inside the square brackets. We're going to say greater than 1. Boom. Or we're going to right shift. Then we're going to come right here, come outside of this, and we are going to say and equals, open up the parentheses, and plus pairs, come outside that, parentheses, we're going to say mod, just like that. Boom. Then we'll come underneath this if, and we will say let target equal num less than this time 1. Boom. Then we're going to come underneath this and we're going to say if let prev count equals count square bracket target, come outside of that, open up the brackets, and we're going to say pair count square bracket num, comma, default, colon 0, come outside of that, we're going to say plus equals prev count. Then we need to record that number that we've sent, that we've now seen num. So we're going to come underneath this outside of the if. Sorry, y'all, this should be it. Come outside this if let. And we are going to say count square bracket num, comma, default, colon 0. Come outside of that, plus equals 1. Now we just need to return the total valid triplets that we have found by coming right here, and we can say return and, y'all. Boom, that should be all she wrote. Let's give it a run. Make sure it runs properly. Okay, let's see. Can I find pair count and scope? Let's get rid of that R right there. And let's run it again. Let's see, it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 106 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.